Alright, so for these problems, we need to solve each inequality algebraically, and then we need to represent our solutions on a number line. So here we have negative 3 times the quantity 11 plus 6x is less than negative 42 minus 9x. So what we need to do first, we want to isolate the variable. So we want to get the variable, in this case it's x, on one side of the inequality symbol by itself. So on the left-hand side here, you can see I've already started, we need to do the distributive property. We need to take this negative 3 and distribute it or multiply it by each term inside of the parentheses. So negative 3 times 11, remember you can draw kind of like a curve like this to represent that you're distributing it, is negative 33. Negative 3 times 6x will give us a negative 18x. So now we have negative 33 minus 18x is less than negative 42 minus 9x. And now we need to work on isolating our variable. So we want to get x on one side of the inequality symbol by itself. To do that, there's many different steps that you could take first. I'm going to take this minus 18x and I'm going to add it to both sides. So we're going to add 18x to both sides of the inequality symbol. When we do that, on the left-hand side here, these 18x's go away. We had negative 18x. We added 18x to move it to the other side. So we're left with negative 33 is less than negative 42, and then this would be plus 9x, because negative 9x plus 18x is positive 9x. Next, I'm going to take this minus 42, and I'm going to use the inverse of subtraction, which is addition, to move it to the other side. So we're going to add 42 to both sides of the inequality symbol. Alright, negative 33 plus 42, again, this is something you can use your calculator for. So you can use a calculator or Desmos. Negative 33 plus 42 gives us 9. So we have 9 is less than 9x, because these 42's cancel out. Now we're almost done. We have 9 times x, but we just want x. So the inverse of multiplying by 9 is dividing by 9. When we do that, 9 divided by 9 is 1 is less than x. So this is the algebraic solution to our inequality. Now we need to represent this solution on our number line. So we're going to start by going to 1 and putting a circle on it. Again, always start with an open circle, because then we can fill it in if we need to. To figure out if we fill it in, let's take 1 and put it into our inequality here. Let's substitute 1 in for x. Is 1 less than 1? Thanks. Alright, so you want to see if the number 1 makes this inequality true. So is 1 less than 1? And the answer there is no. So we're not going to fill in the circle on the 1, because 1 doesn't make the inequality true. So now we need to figure out which way we need to shade. So first let's test some numbers to the left of 1 here. So let's take 0 and substitute it in for x. Is 1 less than 0? No. So we shouldn't shade this way, because that doesn't make our inequality true. Let's try some numbers to the right. Let's try 4. Is 1 less than 4? Yes. Let's try 6. Put 6 in for x. Is 1 less than 6? Yes. Let's try 10. Is 1 less than 10? Yes. So we're going to shade to the right, because these are the numbers, the values of x, that would make the inequality true. And make sure you put an arrow on the end to show that it keeps going. The next one we're going to do here is number 4. So for number 4, we have 57 minus 12x is greater than or equal to 5 times the quantity x minus 9. So now we need to do the distributive property again, but this time on the right-hand side of the inequality symbol. The goal is still the same though, to get the variable on one side of the inequality symbol by itself. So we have 57 minus 12x is greater than or equal to, we need to distribute the 5 through the parentheses, so 5 times x is 5x, and 5 times negative 9 would be negative 45. After we have distributed, we need to get all of our x's on one side of the inequality symbol by themselves. So I'm going to take this minus 12x to avoid having to work with negatives here as much as I possibly can, and I'm going to add it to both sides. So add 12x to both sides of the inequality symbol. Here, these 12x's cancel out, and we have 57 is greater than or equal to 5x plus 12x is 17x minus 45. Now I need to take this minus 45, and remember the inverse of subtraction is addition. So addition and subtraction undo each other. So we're going to add 45 to both sides. When we do that, the 45's cancel out on the right, and again, use your calculator for something like this if you need to. 57 plus 45 is equal to 102. So we have 102 is greater than or equal to 17x. Now we need to divide both sides by 17. Remember, 17x, that's like 17 times x. The inverse of multiplication is division. So multiplication and division undo each other. We're going to divide by 17 on both sides. When we do that, we get 6 is greater than or equal to x. Because remember, these 17s over here make a giant 1, which we can just write as x. Now that we've solved our inequality algebraically, we need to take our solution and graph it on this number line. So we're going to go to 6, and we're going to put a circle on 6. We need to figure out if we should fill that circle in or not. So to figure that out, let's take 6 and substitute it into our inequality to see if it makes the statement true. So I'm actually going to show that down here. Is 6 greater than or equal to 6? Yes, it is. So we should fill that in because it makes the inequality statement true. Now let's figure out which way we need to shade. Let's start over here. Let's test 1. We're going to substitute 1 in for x. Is 6 greater than or equal to 1? Yep, 1 works. Let's try 4. Is 6 greater than or equal to 4? Yep, that works. So it's looking like we need to shade to the left here. Just to be sure, let's test some values to the right of 6 to just double check and make sure we know where we need to shade. So let's try 10. We're going to substitute 10 in for x. Is 6 greater than or equal to 10? No, 6 is smaller than 10. So we're not going to shade to the right here because we have values that don't make the inequality true. To figure out where you shade, you want to see what numbers on the number line will make the inequality true. And so here we're going to shade to the left. And that is your final answer.